Now let us do another important numerical. This type of numerical is very much expected in JEE Main as well as the JEE Advanced, where we have to involve process of integration for finding something. Look at the problem. A charge capital Q is uniformly distributed over a long rod. This black one. This is a long rod. On it, Q charge is uniformly distributed. Uniformly distributed means if you consider 1 centimeter length here, the amount of charge here will be equal to the amount of charge here if you consider 1 centimeter here. 1 centimeter length here, 1 centimeter length here will have the same charge. Means anywhere 1 centimeter will have the same charge at any other point of 1 centimeter, right, of length. Now, what will be the electric potential V at a point O? What will be the at this point due to this charge Q, which is distributed in this rod AB of length L? Due to that, what will be the electric potential here, point O, lying at a distance L from the end A? The length of the rod is L. And from this end, at a distance L, what will be the electric potential here? Right? That is what we have to find. So the length of the rod AB is given as L. And it is also given in the length L, Q charge is distributed. In length L, Q charge is distributed. So in unit length, the charge distributed will be Q by L. I come from here to here by dividing this by L. So I have to divide this side by L. So Q by L is the charge per unit length. Now, from this point at a distance x, that is here, consider a small element of the rod of length dx. This length from here to here is a length dx. So if dx is very small, then the amount of charge will act as a point charge. Dx is equal to a small length of the rod AB at a distance x from O. Dx is a small length of the rod at a distance x from O. Now, then how much charge this small length dx will have? In unit length, the charge is Q by L. Therefore, from here, the charge in length dx will be Q by L into dx. Let it be symbolically represented as dq, say. And we know the expression for potential due to a single charge, that is in electrostatics theory, it was 1 by 4 pi epsilon naught, that charge divided by distance. How this was derived? Suppose there is a charge Q here and you are asked to find the potential here. Now, for that, what we had done, a test charge was brought from infinity to this point. So by bringing this test charge plus 1 unit of positive charge called a test charge from infinity to this point, this is the amount of work done. And that amount of work done was called the electric potential at this point, and that had come out to be V is equal to 1 by 4 pi epsilon naught Q by R. Means if you come closer to the charge, this R decreases, this decreases, therefore V increases. So this was the expression for potential due to a single charge. Now the charge in dx is equal to dq, and this much of charge is at what distance from O? Is at a distance x from O. So due to this much of charge, the potential at O will be using this expression 1 by 4 pi epsilon naught charge divided by distance. So the amount of charge in dx is equal to dq. If dx is very small, then this dq will be like a point charge, and its distance from point O is equal to x. So using this expression, the potential due to this much charge will be V is equal to 1 by 4 pi epsilon naught. This is the formula, Q by R. So for Q, I will write dq. So the small potential, the contribution of this small one towards the potential here is written as dV. dV will be 1 by 4 pi epsilon naught, the charge divided by distance, that is dq by r, and dq is this much. Now, in the whole rod AB, there are many such dx. There are many such dx. dx here, dx here, dx here, dx here, dx here, and all are at different distance from the point O. All are at a different distance from point O. At a different distance from point O. So we have to integrate to find out the. So we have to integrate to find the total potential. So therefore from here, by integrating, so V will be integration of this dV from which point to which point? From this point to this point, that is from distance L to distance this, that is equal to L plus L to L. So if you integrate from L to 2L, then each part of the rod will be covered in the integration. So in the integration, the limit of integration is from L to 2L. So for dV, I now put 1 by 4 pi epsilon naught dq by x, integration limit from L to 2L. 1 by 4 pi epsilon naught is a constant, is taken out of the integration from L to 2L. So dq by x. Now I put the value of dq. So dq was equal to 1 by 4 pi epsilon naught, dq was equal to q dx over L. 1 by x remains as 1 by x. Integration of limit of integrations remains same from L to 2L. Now the total charge is constant, the length of the rod L is constant, so capital Q by L is a constant, is again taken out of the integration. So I am left with from 1 by x from L to 2L dx. Now that is equal to 1 by 4 pi epsilon naught Q by L. Now this is from calculus, is log of x. There are two things, logarithm and this. When you write like this, the base is 10. When you write like this, the base is 2, right? Natural logarithm. So this comes of a log of x from L to 2L. So Q by L. So I put it here, log of 2L minus log of L. In logarithm, if is subtracted, the formula was log of 2L by L. So 1 by 4 pi epsilon naught Q by L this. Now this LL cancels. So 1 by 4 pi epsilon naught capital Q over L, a logarithm of 2 with respect to base E, right? With sorry not 2. This is when it is written like this, the base is equal to E, not 2. When it is written like this, the base is 10. So this comes out to be Q log 2 over 4 pi epsilon naught L. Now let me explain here. Value of log 2 with respect to base E is equal to this much. You can use in a scientific calculator. Log 2 with respect to base 10 is this much, 0.3010. This is 0.693 A1, and the value of E is equal to 2.718. Now what is the meaning of this? E, which is this number, to the power this 0.6931 will give you 2. That is the physical meaning. Now what is the meaning here? 10 to the power this, 10 to the power 0.3010 will give you 2. For example, logarithm of 100 with respect to base 10 means 10 to the power what value will give you 100. 2. So its answer is equal to logarithm of 100 with respect to base 10 is equal to 2, means 10 when raised to the power 2 will give you 100, right? So what is the meaning here? 10 should be raised to what times to give you this value? That is equal to 2. So the answer is equal to 2. So this symbol is used when the base is E. This symbol is used log when the base is 10. And there are similar problems like this in gravitation also, where you are required to find gravitational potential. You will find very similar derivation. Means you will be given a rod like this of mass m, length L, M is distributed from here to here uniformly. Due to this, what is the gravitational potential here? So here the same technique you have to apply here. At a distance x, you have to consider a small element dx, then you have to find out how much mass in it. Due to this mass, you find the potential here dv, and then you integrate that to find the gravitational potential of this rod at this point. Similar problem in gravitation is also there.